All right, we're going to finally finish chapter 11. I know this is a long one. Now that you've drawn the structures, the Lewis structures for molecules, now we can figure out what their actual shape is. Because when we draw them on a piece of paper, they're flat, and they're not flat. In reality, they fill a space, so they're three-dimensional. So there's something called valence shell electron pair repulsion. You have to say it fast. I can't say it slow. It sounds complicated. It's VSEPR theory. But what it does is just you look at the structure when you got it drawn. You look to see how many pairs you have, how many bonding pairs you have, and how many lone pairs you have. And from that, you can figure out the shape. It's actually pretty simple. The hardest part is drawing the Lewis structures. Okay? And again, it's the valence shell electrons that determine the shape of the atom. Remember, you have a central atom, one that's in the middle, and then everything goes around it. So you look at that guy in the middle and see what's bonded to it, if there's lone pairs, and that's how you figure it out. It's actually, I promise you guys, it isn't that hard. It sounds hard. And when you say valence shell electron pair repulsion, you sound like you're really, brilliant. But anybody that knows, it's like, yeah, or whatever. Sorry. Okay, so again, these common molecules aren't flat. When we draw them on a piece of paper, obviously they're flat because the paper's flat. But they have different shapes, okay? Like water is considered bent. We have linear. We have what they call trigonal planar. Anytime you put carbon and you put 4 around it, that's called tetrahedral. And again, it's because these guys are going to situate themselves so they're as far apart as possible. Okay, and you got to use in front and back, not just flat. All right. Okay, so again, when we're using VSEPR, it's if we have one, the central guy, and then we have 2 bonded to it. Okay, if it's linear, that means just straight across, and then our angles are 180. Okay, the way we can tell that is we have 2 bonded to it, and there's no lone pairs. Okay, and there's a chart I'll have you run off, but it says that. It will say bonded to the central atom, 2. Lone pairs, and a lone pair means there's a dots here, and there isn't any. So if it says 0, then it'll say shape linear. Okay, on this one, we'd look, we have 3 bonded to the central atom, and there's no lone pairs. So we'd look for 3 and 0, and this would tell us it's trigonal planar. Okay. Tetrahedral is where you have 1 central atom, and then you have 4 bonded to it. See, 1, 2, 3, 4. And again, no lone pairs, no electrons by themselves. So this one will be tetrahedral. And again, this will be on the chart I give you, I promise. Okay. All right, here we have ammonia. And when we draw ammonia, nitrogen has 5, and then we put the hydrogen around it. So now we're trying to figure out its shape. If you look, we have 3 bonded to it, 1, 2, 3. And again, we just look at the central atom. We have 3 bonded to it, and now we have a lone pair. Okay, this is a lone pair. And what that lone pair does is it has more repulsive force. So these guys, instead of being straight across from each other, they're going to get squished closer together. And so the shape of this one is not tetrahedral anymore. It's called trigonal pyramidal. Okay, so these guys are squished closer together. So they call it trigonal pyramidal. And again, it's on this chart, and I'll show you. But really, all you're doing is looking. Okay, 3 and 1, and that's going to tell you the shape is trigonal planar. Okay, here we got water. Okay, we got oxygen with its 6, and then we bond our 2 hydrogen. Okay, we're looking at this. Okay, we've got oxygen has 2 bonded to it, 2 hydrogen, and then I have 2 lone pairs. So then I look at my chart and I go 2 and 2. Oh, the shape of this one, they say, I think in the chart it says angular or bent. We're just going to go with bent. So instead of being straight across like this, it's like this. Okay, these lone pairs squish them closer together. So that's why they call it bent. Okay, here's the chart of the different shapes. Linear, trigonal planar. Again, the bonds here, and then it doesn't say lone pairs, but the chart I'll give you, it'll say number bonded to the central atom, and then it'll say number of lone pairs, and then it'll tell you the shape. Okay, and here's your different shapes. We have linear, straight across, trigonal planar, tetrahedral, where we have 4 bonds. And then over here we have pyramidal, trigonal pyramidal, because we have that lone pair. Here we have 2 lone pairs, so they get squished closer together. That's bent as well. So these are the different shapes. And again, I'll give you a chart with half these on it. Okay, so if you're going to figure out the molecular shape, The first thing you got to do is the hardest thing. Draw the Lewis structure. You look at the Lewis structure. How many are bonded to the central atom? Okay, so you count how many are bonded to the central atom. Then you look for lone pairs, a pair of electrons that doesn't have anything bonded to it. If there isn't any, that's fine. There doesn't have to be any. But then all you have to do, like I said, I have a chart, and you'll go, okay, there's 3 bonded and there's 1 lone pair. That's trigonal pyramidal. Oh, there's 3 bonded and there's no lone pairs. That's trigonal planar. Oh, there's 4 bonded and no lone pairs. That's tetrahedral. It's really simple. Like I said, the hardest part is drawing out the Lewis structure. Once you get the Lewis structure, it's piece cake. You just use the chart. Okay, so CH2O. Okay, so you'd have carbon in the middle. You'd have 2 hydrogen and 1 oxygen bonded to it. Okay, so that's 3 bonded to it. Okay, and it would have a double bond. Again, when you have double bonds and triple bonds, you guys, you don't have to count them as more than. I hope they have it. It is trigonal planar, but here, it'll be easier if I show you this. Okay, so here's what it looks like. I have 2 hydrogen and an oxygen. And again, I had to make a double bond in order to make it work so that everybody had 8. But now when I'm counting, I don't worry about these bonds on oxygen. I only worry about carbon, the middle guy. There's 3 bonded to it. There's no lone pairs. Yes, oxygen has lone pairs, but I only have to worry about carbon. There's no lone pairs on carbon, so 3 and 0 would be trigonal planar. Okay, that's how you work it out. All that stuff makes it all crazy. Just again, look at it. How many are bonded to the central atom and how many, if there's any lone pairs. And this one doesn't have any lone pairs. I do not worry about the stuff attached to it. I only worry about if there's lone pairs on the guy in the middle. Okay, pH3. I can tell you right now it's trigonal pyramidal because I know this one, but I want to see it. Okay, to draw this, I have phosphorus and then I have 3 hydrogen bonded to it. I mean, you can kind of tell what's bonded just by the formula. So there's 3 bonded, but look at this lone pair. Because phosphorus has 5. So it'll bond 3 and then I'll have 1 lone pair. So this 1 lone pair and 3 would tell me it's trigonal pyramidal. Okay. And again, you count the number bonded and look for lone pairs, and that tells you the shape. Okay. CCl4. And again, let me see it. Okay. If I draw out my Lewis structure, I got carbon in the middle and I have 4 bonded to it. 1, 2, 3, 4. No lone pairs. 4 bonded, 4 and 0 is tetrahedral. And again, I'll give you this chart. Once you get the chart, you'll go, oh yeah, I get it now. Okay, so count the number of bonded to the middle and then look for lone pairs. And if there's no lone pairs, that determines the shape. Okay, all right. So if you're trying to do that, polar and non-polar is simple, you guys. All you have to do is look up the numbers. Remember we talked about electronegativities? I'd look up at carbon and chlorine. The difference between the two, not 4 chlorine, just 1 carbon and 1 chlorine. And then that would tell me which one it is. Okay. Again, you don't have to worry about that. We're not going to spend time on that. We already did polar and non-polar, so we're not going to worry about it. Okay. CO2, carbon in the middle, 2 double bonds, 2 double bond oxygens on each side. Okay. All right. Carbon's here. And even though I got double bonds, you don't have to worry about those, you guys. All you have to do is say, oh, here's carbon and it has 2 things bonded to it. And there's no lone pairs. So it's linear. The other one that gets people confused is if I ask you, what is the shape of N2, 2 nitrogen? There is no central bond. It's only 2. Anytime there's only 2, it has to be linear, you guys. Okay. The VSEPR is for when you have one molecule in the middle and stuff is bonded to it. If you don't have a central atom, it's always linear. Okay. That's the shape. Okay. Okay. We don't have to worry about the video. Okay. So again, when you're doing the shape, all you have to do is draw it out. And I realize that is the hardest part. Then once you draw it, then you look at it. What is bonded to the middle and what is, if there's lone pairs. And again, the lone pairs are only on the guy in the middle. If it's a molecule made out of 2, like if it's H2 or N2 or HCl, where you only got 2 atoms, it's always linear. Okay. You can't use VSEPR because there's no central atom. And again, I will have that chart for you. Once you look at the structure, it'll be easy for you to figure them out. Okay? All right, we're done with chapter 11. Yay.